Welcome to the Conversion Science and Instrument Forum podcast on collaboration. I'm Paul Verschoor, and together with my colleague Julia Loop, we speak with Dr. Sijbrand de Jong, Professor of High Energy Physics at Radboud University, where he's also the Dean of the Faculty of Science and Technology. Sijbrand is an expert on elementary particle and astroparticle physics, and he's a member of the CERN Council. Having conducted high-energy experiments at large accelerator laboratories such as CERN, Fermilab, and the Pierre Auger Observatory, he reflects on how large-scale scientific collaboration is carried out.
Sijbrand, welcome to our podcast.
Hello, good afternoon.
And Sijbrand, so before we really delve into the questions around collaboration, what would be very helpful if you could situate us a little bit in your background and in your career path that brought us together today.
Okay, well, I'm not completely sure what brought us together today, but I can certainly sketch my career path. So by Bildung, I'm a physicist. So I studied physics, but also I have a keen interest on mathematics, computer science, and astronomy. So I also picked up parts of that in my study. After graduating at the University of Amsterdam, I did my PhD research with NICEF on already on a large experiment, so large experimental collaboration in Hamburg on the Hera ring at the DAISY laboratory. Of course, there I was as a very junior member of that collaboration. From that, after obtaining my PhD, I moved on to CERN. I've been for 8 years at CERN as a CERN fellow and a CERN associate, really working on another large experiment, the Opal experiment at the lab ring. And then after my stint at CERN, I came to Nijmegen. Somehow I called it coming back to Nijmegen, but I'm not really from Nijmegen, as many people will hear. I'm of course from the area of Amsterdam. But ever since I've been in Nijmegen at what first was called the Catholic University Nijmegen, and now it's called the Radboud University. And there I served in several managerial tasks. So I've been a department head. I've been the director of the School of Physics from 2000 to 2004. After that, I was the founding director of the IMAP Research Institute for Mathematics, Astrophysics, and Particle Physics. After that, I founded the Radboud Pre-University College of Science, so an interface to high schools. And then I moved on to serve on the CERN Council and the last 3 years as the CERN Council president. And of course, meanwhile, I did many things in both together, always simultaneously in research and in governance and management. So far, I've been able to always combine it. So from the 1st of December on, I will be the Dean of the Faculty of Science. And now for the first time in my life, I won't be able to combine that anymore with doing really science myself. Mm-hmm. So I had to give that up. And I'm still sort of in the process of getting accustomed to that.
Right. Understood. Well, that's an amazing career up to this point. But then, in the context of that experience, how do you define collaboration, and what is it good for?
Well, collaboration already is a very interesting word for those who are not Dutch listening to this podcast. Collaboration in the Netherlands means quite the opposite, I guess, from what it means anywhere else. So in Dutch, it's like siding with the enemy. Which is, of course, more or less the opposite of collaboration. I've always been working in large experimental collaborations. So typically ranging from, my very first collaboration I worked in as a master's student was only like 60 people. And then it scaled up from hundreds to thousands. So for me, it's sort of a natural way of dealing with say, large and complex situations. So in that sense, it's sort of my habitat. My natural habitat is working on these large collaborations. And these collaborations, they do, of course, there's the common goal, which is very unifying normally. But of course, there's also a lot of fighting, a lot of infighting, a lot of fighting between colleagues, because these collaborations are usually formed from I've been in collaborations with over 1,000 full professors. And of course, they're all king of their own empire. But then in a much larger context, they have to work together as equals. Okay, and especially depending on nationality, that gives more or less problems.
Mm-hmm. So, but then how does that work? So, if you look at these larger, the ones you just described, the really challenging ones, why would it work and why does it fail? Could you describe that or give an example?
The foremost thing why it can work is to have a recognized common goal. Typically, the cycle in a large experiment is that people dream of doing something spectacular, and then they find out, okay, I can't do it alone. Okay, so I need companions to do this. And then they round up a couple of friends, and then the circle gets larger and larger. And then at some point, you have like the volume to jump into the big enterprise. Of course, at that point, everybody is very enthusiastic about the common goal. And then usually things like letters of intent are written, which are, of course, a letter of intent. It sounds like a letter, okay, but usually it's like a few 100-page book. With quite detailed prognosis of what you want to do and studies on how you're going to do it, etc. So at that point, there's still like one community. Then the trouble actually starts when these things get approved. Because then suddenly, like the first hurdle, the first goal has been taken. The approval is there. Okay, so what do we do? Now then, of course, typically there's years between a new collaboration approved and a large apparatus really being built. And so there's lots of designs in between. And this design phase is usually like a huge fight. It's like a huge cage fight. Because you're condemned to one another, yet you want to kill the enemy. Okay, you want your idea to prevail. So it's really like a cage, an enormous big cage fight, okay? And then all sorts of things come in. So not only the scientific argument of what is best, but also in the end, like, okay, my idea is maybe second best, but I pay for it, so it's my idea that's going to be built. And actually, this is one of the better arguments. Okay, there are worse arguments that make people win, which I won't go into. But okay, and then the sort of at some point, okay, this fighting takes usually a lot of time and a lot of energy. People do this actually typically for years in these large collaborations. And at some point, I realized, like, oh, gee, we should have started building half a year or a year ago to make it for the deadline of, say, the accelerator to be finished or the promised start of the project. And then sort of there's usually there's first a panic. Then, of course, there's a lot of blaming and shaming on who's guilty of this. And then people realize, like, okay, this doesn't help. To actually pull it together, we have to really work together again. So then there's usually a very rapid stage of convergence, typically like in months, where people realize, okay, we just and then people just tend to be more soft on giving up some of their own ideas, etc. Like, okay, anything, okay, as long as it's been built. And so then there's this phase of building where people are pretty much unified. And then you, at the point where the whole thing is going to be commissioned, there's usually like a great group spirit, okay, where things tend to work together, sometimes miraculously. There's also great satisfaction and group identity and big parties, sometimes parties of thousands of people. We all believe in Corona times. And then, of course, you have to start the experiment. And usually the first few measurements are, again, like really like the core business. So everybody's unified, big success. And then you get into the stage where you have to accumulate more data, and to either supersede the first publications or to do something entirely new. You just need so much data that you need to wait for years. And then people start to fight again, because then it's one analysis against the other, because they're basically waiting for data. They get a little bit bored. Okay, the initial successes are over, and the goal becomes sort of fuzzy. So my conclusion from all of this is that it's all in the goal. Okay, if you have a strong common goal, you can get people working together.
But
it was a long story, but
no, it's very
the
good.
conclusion is relatively simple.
But Sijbrand, if we focus on the goal as the unifier, is that really enough? Because in some sense, it's also at some point also these phases that you describe, right, of infighting, coalescing again, and so on. In some sense, now you also have a limited resource that you have to share in order to achieve your selfish objectives. So that is now a new element that comes in. So is the goal then actually still the same?
Yeah, but that's okay. So again, okay, the resources can play both parts. Okay, so of course, when the project is defined, everybody realizes that okay, I cannot pay for this on my own, so we will have to share it. And then everybody, of course, immediately agrees that yeah, of course, if we have to share resources, we also have to share responsibility and share tasks and okay, fine. No problem. But then, especially in this design phase, okay, when people have already committed basically their resources, then it's like, yeah, but you give like 1,000 and I give 10,000, so I can tell you what you should do. So there the resources are abused again, okay? And then when things have to be built, usually there's yes.
Before we go to that stage, I want to back up again to the goal, because you're talking about recognizing a common goal. But how is that common goal constructed? In other words, if you have a collaboration of eventually 1,000 people, are 1,000 people involved in constructing the common goal? Who constructs that common goal?
Okay, well, again, okay, so usually, of course, there's like a couple of people that really pull the cart, okay, that really express the goal, and usually those are the people that can sort of make good presentations, present it in a very nice way so that it's convincing. But usually these goals that are then defined by individuals already are like living in the community for quite some time. So and that's where people then recognize it, say, yeah, I thought the same, and then they join this collaboration. Of course, also projects actually exist where people are so much ahead of the troops that they have marvelous ideas. Okay, but if it's not living in the community, okay, then
it won't be taken up.
They consider that they have this brilliant idea, and with the three of them, okay, and they have to find like $500 million with the three of them, and it's not going to happen.
But on Sijbrand, do you see a stage where the people who might be in front of the troops start really an active, let's say, campaign?
Yes, that's usually what is being done. Okay.
Okay. So how is that structured?
It's just like going for it. Okay. So you have this idea, and then typically you try to get conference talks. You try to get, and also what is very powerful in our case is you try to get invited at certain research institutes. You present your case, and especially you go with these people for lunch and maybe dinner, and you try to convince them that it's really good case and that it would be really marvelous if their group would be joining. And the other thing that is in the first stages is that, of course, at that point it doesn't cost anything, so it's practically resource free because it's just an idea.
Mm-hmm.
So you join this collaboration, and then it's just we sort out the business later. Okay. First, join us, okay, and do a few studies and run a few simulations and see what you can contribute to the goals or to the ideas of realizing the goals, and then we see. This is usually how a collaboration is formed, and when it's then sort of it acquires it goes over a critical mass.
Mm-hmm. But then
you start looking for resources, and then actually this helps because you're already tied into all the other organizations, the universities, the research institutes, etc. And then each of them has to fight in their own institute for a piece of the pie.
Right.
But that means you first build a coalition in some around the idea, which is a process that has psychological, social components to it. Yeah. Does that also lead to, let's say, a regression to the mean of the idea? Do you see that also as a compromise?
Yeah. Yes, of course. That's like I said. Okay, at several stages, sort of the idea is watered down. There's no question about it. Usually in the goals, okay, if you're still in the dreaming world, okay, you can actually stack goals, so it doesn't matter too much. Then when you get into the stage where you have to secure the resources, then that's the first time you're confronted with reality. And then you find out, okay, maybe you have to descope a couple of things, or maybe you have to descope many things. And then usually, of course, the people that can secure the money, okay, can secure the resources, their ideas will prevail. Of course, usually also a couple of good ideas that are in common to everybody will also make it. Okay, there's no doubt about that. But then some other ideas of people that are less resourceful, they will have to go because you have to compromise on that. And in fact, it's true that sometimes good ideas go. Huh?
Right.
Mm-hmm. Right. Exactly. But then now you form your consortium in some sense. Now they start to compete with other consortia to dominate for the resource. But now the whole process is extended over years, right? So what's the what's the duration of such a process? 10 years?
Okay, so in our field, the process of doing an experiment is typically that you have a phase of 5 to 10 years, which we call proto-collaboration. So that's when the collaboration is formed. Then typically you have a phase of 5, sometimes even to 10 years, where you try to secure resources. It's also true that you never secure the resources that you really need. So you have to decide at what point you're just go. So typically at 50-60% of the resources pledged, you just go and you hope for the rest. Typically, by the way, this is a mechanism because this is like with all sort of large public projects. If you go over a certain volume, it's too big to fail. So typically you will get. So typically what happens is you find 50 or 60%. And there's not so much problem in finding another 30%. It's usually the last 10% which is a problem. Because then the argument of too big to fail doesn't work anymore. And for that you have to descope. This is typically also a pity because descoping for the last 10% actually means that typically the apparatus only works half as well. Mm-hmm. It works like that, okay? Which is something that funding organizations do not always realize. But yeah, this is how it goes. And then there's the time of construction. Again, time of construction in our field is by now 5 to 10 years. And then there's the time of exploitation, which is typically in our field now going up to 20 years or 25 years. Mm-hmm. So you're talking about
40 years.
You're talking about people that actually can spend their entire career doing one project.
Right. Yeah, but this is important, right, to understand, because now the question becomes, if the goal is so critical in keeping this together, how do you assure that goal also stays intact over that whole period, is propagated properly, and is also that you don't have mission drift, right, so that the goal fragments?
No, that in our case, okay, I've never seen that really happen.
Mm-hmm.
So the goals are typically so well, like these are typically already questions that are that are decades above the market. So really big things that we want to solve. Okay.
Mm-hmm.
What are the most interesting cases of mission drift? Of course, is that you build something for a certain goal, and then the thing is built, and then you switch the apparatus on, and you look at the data, and you just find out something completely different.
Mm-hmm.
We don't call this mission drift. Okay, it's just like, okay,
you adapt.
Huh?
Your goals would adapt if in the implementation stage you find new information that will change your goals or bring you.
Yeah, typically the old goals are still there, but sort of you acquire new goals, and sometimes the new goals sort of overshadow the old goals.
Mm-hmm.
So famous for that is that there was an experiment that tried to look at decay of protons, okay, proton and elementary particle, and it's predicted to decay, but with a very long lifetime, because otherwise it wouldn't be sitting here. And so you need a huge detector, and then you look for the one proton to decay, one in enormously many protons. So they build a huge detector, they wait for this proton to decay. And what they found out is that for a completely different particle called neutrino, they actually did some measurements which were done by the PhD student because, well, they have to do something while waiting for the proton to decay. And they actually found out that these neutrinos, they change their nature. So a neutrino could start as one particle, and after some while could end up as a completely different particle, still a neutrino, but a different neutrino, okay? So they could completely sort of change. This was a fantastic discovery.
Yep. But the thing is, if it runs over such a long period of time, that doesn't also mean you have different generations. That's, for instance, the first push given by a senior generation that in the end also will hate each other so much they cannot go on. But then it's a younger group that comes in to push you to the next stage.
No, that's part of the dynamics. Typically, it's the old people just before or just after retirement that dream of the new big things that they will actually never see working alive. Mm-hmm. And then in the process, of course, they drag on the younger colleagues. And the most interesting thing is that the peak of say the young colleagues joining the collaboration is typically when the experiment is already running for a while. So in the last stages.
Mm-hmm.
So and part of it is because the old guys in the experiment then are already busy with dreaming up the next project.
Right.
So, it's sort of, so we go from old to young in these collaborations. Typically.
Right.
The average age goes down in steps, but it goes down along the way.
Right. But so now we looked at this important challenge of goal setting and then how this might be maintained or might also change. But you also mentioned that there are these serendipitous discoveries that were not part of the original path. On the average, how is that balanced? So if you look at the high impact outcomes of all these huge experiments, are most of them on the critical path of the original goal, or are they on this serendipitous offshoot?
No, typically for all the experiments that I know, hardly any of them actually have failed to fulfill their initial goal. Mm-hmm. Of course, sometimes you're looking for things and the things turn out not to exist, which is among the public, then it's called a failure. But we think actually this is a success because that makes a paradigm shift, because we always thought something was there. And now we discover it's not. Yeah. So that is a big discovery, basically, for us. Okay? Because that means that you have, like, your common theory doesn't work, which is a big overturn of the thinking.
Exactly.
So in that sense, the goals are nearly always met. Like either you find what you were looking for, and in fact, personally, I always find, like, you have this theoretical idea and you set up to check it, and then you check it and it turns out to be true. Yeah. It's like ticking a box, okay? It's really boring.
Mm-hmm.
So it's much nicer if you don't find it or you find something completely different.
Right. But so now we looked at the goals, we looked at outcomes. But as you mentioned, the process is complex and also contentious. There are phases where people, like you said, a cage fight. Now, another aspect of collaboration is that also the different participants at least have a sense of trust in each other and in the process to move forward. So how is trust then defined and maintained in such a complex process?
Okay. I don't know how trust is defined, but it turns out that even in these cage fights, okay, or at the end of the cage fights, people make up. So they still know that they are condemned to one another. Okay, there's no way they can have an exodus of people. Like the famous thing, okay, we have is that very often we have like 3 ideas on a certain detector construction, and they're nearly equally good. And of course, there are some deciding criteria, and you could sort of say who's best, okay, but the second and third best are not so far off. And so I heard one spokesman say, like, whatever I do, okay, I will lose 2/3 of my collaboration in this decision. And this is true. But we also know that if you lose 2/3 of your collaboration, the whole thing is not going to happen.
Mm-hmm. Yep.
So people also know that they can be sore about things, okay, and they can what do you do then? Okay, you kick in a door or so, and then you go home, and
but how do you
after a little bit of sobbing you return and you say, well, how can I help?
Okay, so you give in the end. But is trust not based, because in that sense physics is a very unique domain, right? It's one of the few, to my knowledge, the only area in science where people succeed in pulling off these huge collaborative initiatives. But isn't that also not related to the availability of, let's say, a theory that everybody trusts in some sense?
There's the
framework.
Yeah, that's also true. Okay, so there's, like I said, that's also why there is so little goal drift. Okay, because usually the goals are already sort of stably defined, and it also plays a role in what I said about that there are a few forerunners that propagate, that promote ideas, but there is lots of followers that already thought like, well, I had the same idea, okay, so I can as well join them, and then we'll make it to success together. So it means that the meme is already living in the crowds.
Mm-hmm. Exactly.
Perhaps
and that, of course, has much to do with like an underlying theory, which is commonly believed in and relatively stable. So it's not like we change theory every couple of years.
Right.
And so what you're saying is that the trust is in the thing itself, in the ideas, in the concept, and not so much interpersonal trust. Is that what you're saying?
Oh, there's also interpersonal trust. There's also interpersonal distrust. But the interesting thing is that even people that have mutual distrust, in the end, will work together and really cooperate.
Is competition in this sense a positive thing for the outcome? I don't mean competition over funds, but I mean competition in terms of ideas.
Yes, I think overall, yes. So what the competition makes is that people are just sort of working harder, going the extra mile in developing their ideas and in presenting their ideas and getting the details right, because they know that if any of these, okay, has a little flaw, then they will be shot by the other party. Mm-hmm. So in that sense, it works very much elevating the quality. On the other hand, okay, practically always it's like not quite the best idea that wins, but nearly the best idea. Mm-hmm. But then my feeling is that nearly the best idea then would still be much better than in the case if there would have been no competition.
Right.
See, it's actually quite subtle, the whole thing.
Right. But now, if you have competition about ideas in science, there are very strict mechanisms also to express this competition as for instance, in the critical dependence on peer review. So do you see that people also use that mechanism to dominate or win in that competition?
In which, because I'm trying to figure out what you mean, okay? So if one party has to sort of be the referee of the other part.
Exactly, yeah. There's interdependence, right? In the background, there's interdependence because everyone is in some sense a potential reviewer of everybody else.
Yes. And in our fields, they're more or less permanently because it's sort of in the open.
Mm-hmm.
So I think it's not that, okay? It's not that influences things so much.
Mm-hmm.
What does influence things is that, of course, some people are more powerful than others, and so there's also a lot of backroom policy.
Mm-hmm.
So a lot of, I mean, basically all the important decisions are taken in the cafeteria.
Mm-hmm. Right.
So there's a lot of wheeling and dealing and hassling, okay, to set up certain people against other people, etc. Okay, so there's, of course, there's also physicists are completely human.
Mm-hmm. Yes, but now you have been at different sides of this process. You have been in the middle of it, but also if you had the board of CERN, you have to manage it. So do you then, from that perspective, are you able to really manage and or engineer that process by, for instance, bringing people together in certain ways or setting up forms of communication?
That's also where we distinguish things. Okay, so I was not in management, I was in governance, which is a different game. And in fact, most of the structures are set up in governance, not by management. And actually, this is an important distinction, because in governance there's a little bit more distant, because the governance is always over a number and maybe even a large number of projects. So it's more like a mechanism that would fit all the different things, okay? While management is much more trying to tailor things to a certain situation, and it really helps that the structures are set up from a more global perspective.
Mm-hmm.
Because if you, I've also seen structures that have been set up to tailor the situation, and they nearly always end up getting messy, because they were so much tailored to the situation that when new events arise, they have to be adapted, and then you have to add on things, and you have maybe to scrap a few things and add on more things. Okay, and it should sort of get a biologically grown structure.
Mm-hmm.
And in the end, that is very advantageous for the cowboys, but not for the sort of straight thinking people.
Yes. No, but also then the management becomes part of the situation to be managed.
Yes,
right?
Exactly. Okay, exactly. So,
but then from the governance perspective, what you can do is put in place procedures, protocols to try to structure, right, the collaboration. Now, for CERN, did you also do that in a very deliberate way? That you also knew,
yeah. All the things are structured very deliberately. Okay? So the idea is to have peer monitoring on practically everything. Mm-hmm. So that's an important thing. And so those are people that are in this peer monitoring that are very knowledgeable about what is going on, but they're completely independent to both the thing they monitor and to the body they actually report to. So also it's not like the body that is in the governance is actually arranging the monitoring, but it arranges it through a third party, which is an independent monitor. So they can also sort of say things that are not very much to the liking of the governance board, okay, and without consequences. So and that is a very powerful structure.
So peer monitoring is a quality control system, but that has to operate on let's say protocols of, let's say, communication, responsibility, So are you also structuring those then in a very specific way? Like hierarchy?
Well, this monitoring is usually sort of there's not in our case there's not so much hierarchy in the monitoring. Okay, so there's monitoring at in principle at a rather global level, but they're allowed to actually go into the detail.
Mm-hmm.
So it monitors a large span of things. So I've been into so part of my career I've been into one of these monitoring bodies, and on the one hand we were dealing with bolts that we should make sure that they were not containing any magnetic material, and on the other hand we were of the spectrum we were also dealing with the accountancy of material requisitions and how this was done and how this was monitored and whether all sorts of buying procedures were in place, etc. So over the whole span, we were actually. But
I'm a bit confused now. Because the monitoring I understand, but the monitoring will very often have to refer to certain standards, right? To look at different parts of the process, and these standards also must be defined. And I would assume that's also part of the governance structure.
Well, okay, that's the other interesting thing. Okay, so the real monitoring is done by committees which have very little constraint.
Mm-hmm.
So.
And who establishes the committees? Who establishes the committees?
The committees are established by the governance structure.
Okay.
So of course there's a subtlety there because usually they are proposed by management, but then have to be established by the governance structure. Yeah.
But that sounds very loosely defined then, because that would also mean
that part is loosely defined. Okay, actually the strict standards are of course things like safety, accountancy. That they are quite strictly defined. Okay, but since we are in the process of building things that have never been built before, it is very hard to set standards for this. Okay. And when we go for the common sense of the people in the review committees or in the monitoring committees to see what is right and what is wrong.
But then you don't try to then extract a rule book or so, or a playbook from successful projects to say, well, this was the playbook of this project and this could be standards for a future project.
Oh yeah, so but that's again not in the sort of in the monitoring side, but that is in the implementation side, so on the management level. And yes, there is also like a strong idea of how the collaboration is formalized, and there are variations on that. But if you look at it from a distance, okay, then you see that the overall structure is the same, and the variations are minor.
Mm-hmm.
So one of the interesting things about these large collaborations, for example, is they don't have a boss.
Mm-hmm.
So the acting boss is called spokesperson.
Mm-hmm.
So traditionally, that was the person speaking to the management and the press. And when there was to the management to say how things were going, and to the press to say what they discovered. And basically, that is the person now who is in charge of a collaboration.
Mm-hmm.
But that person has no personnel. So there's no hierarchical relation between that person and the rest of the collaboration. Yeah, usually it's somebody from a larger group, so he has like some of his group members. But typically in a large LHC experiment, like 3,500 collaborators, then the spokesperson has like at most 20 people that he or she can fire.
Mm-hmm.
And all the others, okay, there's no leverage.
Okay. How is the spokesperson?
So you have to do it on persuasion, and the spokesperson is elected.
Okay.
Mm-hmm. Okay.
So collaboration. So and that actually that is an important thing, because that gives credit. So you're elected, and then of course your your power in the collaboration comes from the fact that you were elected. Okay, and you can always say like, okay, you don't like it, then you shouldn't have chosen me. Okay,
right. But people also vying and competing for this role of spokesperson.
Yeah, of course, this is highly prestigious. And again, okay, so there's like the formal thing, okay, of there's the competition, and there are usually several candidates, and then there's the voting, and then there's all the things that you have in a voting process, like people try to gain votes, and they make all sorts of promises, etc. But there's also that is maybe different from a normal democracy, or at least from a national democracy. There's a lot of things going on behind the scenes.
Right.
So there's a lot of trading. Like if I become spokesperson, then this and this person from your institute gets this and this position in the collaboration.
Right.
Okay.
One thing. Okay, as we the Dutch are very not good at this. Okay. So that's why Italians always win.
Why
they're much better at these things. Okay. We always think that it should be fair and honest, etc. Okay, and they don't care. It should just be effective.
Exactly. That's also something you mentioned earlier, right? That there were cultural differences in how people approach that process, and without necessarily wanting to hear you say certain stereotypes about different cultures, still, it would be useful to understand how these cultural backgrounds make a difference in how collaborations get built up and work or fail, right? So what are the basic dimensions there?
Well, again, okay, so in these large collaborations, it actually helps to have a lot of culture, because some of them are more risk-taking than others. Some of them are more solid than others. And if you somehow can deploy all these qualities more or less in the right places, then it's a very powerful combination. And so again, okay, this is in the process. So usually like the more risk-taking people, they're the ones that with the big dreams and the fancy ideas, and they try things. And sometimes they succeed and often they fail. But sometimes you get very good ideas from that. And then in the end, okay, you have to have an apparatus that actually works. And then there's also a large part of the community, which are just like very solid working people. And apart from the one or two highlights where we have a fantastic idea that works, most of the apparatus is actually built on like steady progress. And so, but this combination is quite powerful. And again, okay, you never get it perfectly, sort of everybody in the right position.
Right.
But there is a sort of a natural selection on that, because the risk-taking people, they tend to focus on the parts where they allow to take a risk. The people that are delivering solid work, okay, they would go to places where their solid work is appreciated. So there is some sorting out mechanism, okay, with like that the nature of people sort of fits with the thing they're doing.
Right. But then who are the real players in this context? Who are, in the end, managing to grab the most control over that complex process? Like you say, these are more the Italians or the Americans, the British. Who are the strong players there?
No, in the end, often, okay, so what you see is like spokespeople, etc. They're very often like more of the risk-taking types and the outgoing types. And then there's also a very important role in all of these large enterprises is something we call technical coordinator, which is just what it is, okay? So it's like the person who coordinates all the technical stuff. And therefore you need a very solid and stress-resistant person. And that selects itself, okay? Because typically people that are not robust and stress-resistant will actually disappear within finite time.
Sure. But now we looked at the process. Can you give an example of what is the biggest success of your time at CERN, and what was the biggest failure, and what's the difference between these two?
Of my time at CERN, I had, of course, different times at CERN.
Oh, no. So you can choose.
Okay. Well, by far my biggest my biggest failure, I consider that I lost the detector. So I was responsible for a detector which actually melted. And it was not a small detector. It was actually a fairly substantial part of a large detector.
Mm-hmm.
And that was because basically not all the security that should have been there was in place. And then there was a series of human failure in my absence. But okay, I still was responsible for it. So that was...
How does it reflect on the process of collaboration? That was a failure of collaboration? Or there was a failure of you just not being there?
No, it's no. It was a failure on my part of sufficiently recognizing human weakness and trying to exclude the risks associated to that, with the fact that there was like a sequence of human failures, so a highly unlikely sequence. And then you can say, okay, well, normally this wouldn't have happened. It's not your fault, etc. But any of the failures that was there could have been prevented if the right procedures would have been in place.
Mm-hmm. Right.
And so in that sense, because after that you immediately see, okay, if we had done this, and this, okay, then this would not have happened, and it would have been prevented in at least 3 or 4 different things that would not have failed. But of course, and what you learn is that to even be more careful and thinking out all the possible scenarios of what, and even if you think like, well, who on earth would do this? Okay, if it can be done, somebody will do it.
Yeah, exactly.
So yeah.
No, but in terms of the collaborative projects and installation.
Yeah, what was interesting is that in that case again, okay, so this was a case in which the experiment was actually coming to a grinding halt. Not only that, there was actually one experiment out of 4 on the lab accelerator, and so the accelerator had to be stopped. So the other 3 experiments were also victim. So it was a big thing, because you also have to realize that running costs of these things are about $1 million a day, and this failure took out like 1.5 months. So it's not like small problem.
So now you're the $60 million man at CERN.
Well, yeah, no. This was spelled out to me very explicitly when I had to go to the directorate to explain how on earth this could have happened.
Mm-hmm. Yeah, but I didn't want.
So you feel very tiny at the time, okay? But I had nothing but support.
Mm-hmm.
And even from the director, it was not like, okay, of course, this is really bad. But the immediately, like, there's a switch, like, okay, how do we recuperate from this? How we get back on track?
Right. But what do you see as the biggest success then of these large scale experiments over the last decades? What's the biggest success story?
The biggest success. Okay, so well, the biggest success of there's several dimensions. So of course there have been like marvelous discoveries, expected and unexpected, and we have a very different view of our universe actually from the discoveries of the last I would say 3 decades. So this is one asset from these enterprises. The other asset is that we have this worldwide collaboration. So there's like, I don't know how many nationalities involved, 180 or so, like practically all nationalities in the world, peacefully cooperating. Okay. I've seen Israelis and Palestine doing shifts together and actually getting along, etc. So I consider that also to be a big success. And then probably the biggest success for society is that we educated many people in performing state-of-the-art, beyond state-of-the-art things in large collaborations in an international setting. Mm-hmm. And of all the people that come to to these large experiments as a master student even, or a PhD student, or a postdoc, in the end, 90% ends up not in research, but in some other part of society. And there they play a large role. For example, the whole of ASML would not have been possible if not for the science that we do. And not in terms of that we invented what they should do, because we didn't, but we deliver the people.
Right, exactly. So what's go ahead, Julia.
Sorry, Paul. If you were to construct a future major collaboration using your knowledge of what works very well, using your knowledge of the frameworks that you had in place, but mindful of the fact that failures are inevitable in areas of science where there is not a basis of already understanding mechanisms, as you say, in many of the parts of the project. How do you try to compensate for the unknown when you are constructing a collaboration?
Compensate for the unknown when constructing a collaboration? Well, I think the sort of the best robustness you can gain is by having a pluriform collaboration. Okay, to have many talents on board. That is actually the main mitigation mechanism. Is that if something fails, you have so many different angles to look at it that you fix it again. And also before it fails, to have so many different angles to look at things that failure is avoided. And there again, this competition within collaboration plays a large role, because if you're competing for building the same piece of equipment and you see a flaw in the other ones, okay, you would not hesitate to actually say this will never work, or your thing will burn down on the first instance because, etc. Okay,
but is that?
I think that's probably an important thing, is this competition in collaboration and the diversity of talent.
But are you also describing a sort of humility in the face of the challenge, that therefore also people give each other space? Is that also what you were expressing here?
No, I don't think it what I say, people only give other people space when they are more or less forced to do so. In times when things are more relaxed, okay, they don't get a millimeter.
Okay.
And it's not. I think humility is not one of our virtues.
Okay. Well, but I was thinking more about humility in the context of the theories that people try to pursue. Because there, of course, you enter highly complex conceptual frameworks that not always everybody understands all aspects of, where you also need to have a sense of a common approach towards the more challenging scientific objects that you're dealing with.
Yeah, but I'm not sure that. Okay.
There's someone might.
It's not like we're sort of in awe of the big things, okay? Because that would be sort of freezing us. So in that sense, there's no humility, okay? We think we can find out how nature works. We really do. It's probably not true, but we really do.
So there's a lot of confidence there, I understand.
Yeah, because why would you otherwise embark on such things, okay? If you think you're not going to understand it anyway in the end, okay, you better play golf.
Well, but you could also see it like the constructs are of a certain complexity that I need to be in a continuous dialogue with others to get my head around it.
Yes,
I'm not going to solve this on my own.
Oh yeah, no. Most people realize that, and of course there are also some individuals that think they know it all. But most people realize that they need all these other input from all the others. And it's I think by now it is probably you cannot find anybody anymore who is actually even willing to claim that he understands one of the large experiments like completely.
Right.
And so in that sense, but it's not humility. I think it's because many people would like to, but they feel forced to be realistic.
Mm-hmm. But understanding the limits of your knowledge is a form of humility that stands in contrast to overconfidence, right?
Yeah.
That balance.
No, okay, but I would rather sort of phrase it in terms of optimism and pessimism, okay? And there again, in the collaboration, you find these hopeless optimists, okay, who think anything goes. Mm. And then you also have some group of people that are always like, will not work, will not work.
Right, exactly.
Okay, and they both have a function.
Sure.
Okay.
So Sijbrand,
it would be unhealthy for a collaboration not to have these groups.
Yep. No, that I understand. So before we go to the final stretch, I want to understand a little bit the continuity of large-scale projects in physics. So is it fair to say that the Manhattan Project was the first one?
Oh, that I don't know. That was really like a huge constructed project. But of course, well, wait a minute. Before that, okay, the Manhattan Project is basically the answer on a sort of much larger scale of German projects. Mm-hmm. Both for building an atom bomb, mm-hmm. and also in rocket science, to call it that. Okay.
But that scale. That's my point.
So they were also of a certain scale. Okay. Mm-hmm. And actually, then the Manhattan Project, of course, was independent, and they really made it happen. But it was like really like power. It was an enormous project.
Yep. But it was not the biggest project during the war by the US. It was the second biggest.
Sure. Right, okay.
The biggest one was for the B-29 Superfortress.
Yeah. Okay.
So, but my question would then be: was the dynamics and the organization of these early projects, like the Manhattan Project, already anticipating how they run today at organizations like CERN, or was there some transition point?
No. Okay, that's an interesting thing. Okay, because of course the Manhattan Project was really run as a military project, mm-hmm. and since then that has been tried one more time for one of our projects, which was the SSC, the superconducting super collider, which ended up in demise because it was at some point really converted into a military operation, really with military leaders. And that doesn't work with us. Mm-hmm. Okay, it's all about the goal. So it probably worked if you have like a world war going on, mm-hmm. but it doesn't work for anything less.
Right. Yeah, right, exactly. So how much is your science worth to you?
Yeah, it's a lot worth, okay, but mm-hmm. that running that as a military operation didn't work.
Right, exactly. But now, if you look forward, and also if you look at the current situation we're in, we have two big crises in front of us: the COVID pandemic and ecological collapse, sustainability of the planet. Do you believe that our society could learn something from the rule book of these large-scale physics experiments?
Okay. Well, first of all, I'm already I hear a lot of people doing it, so I'm not surprised anymore. But I think there's quite a big difference between COVID. Of course, COVID is just hitting us now very hard, okay? But COVID is just a ripple compared to our ecological problem. Mm-hmm. Okay? COVID will go over. Our ecological problem, probably not. Mm-hmm. So it's of a quite different scale. And so what maybe I think people in my field, and I think many people in my field are of the same opinion, if not most. Because I think in my field, people can actually look like 20, 30, 40 years ahead and look at it in that perspective. Mm-hmm. And also when you talk about COVID, okay, it's not COVID-19 which is the problem. It will be COVID-22, COVID-25, COVID-27, COVID-28, COVID.
Or a completely different virus, right?
No, that's why I labeled them all by year.
Right. Mm-hmm.
This is how it's done. But we're not done yet with that type of vulnerability, and so that requires something different than what we're doing now in fighting this one virus or even this one type of virus. So we have to
the question
about how we organize this.
Yeah, but Sijbrand, the question: Can we learn from you guys? Can we learn from you guys to then respond?
Well, exactly this. Okay, that if you, of course, it's important that that next week we cannot go to a cafe anymore. Mm-hmm. Well, is it? Is it really? Or is it that over the years, okay, we will have a very limited life for 20 or 30 or 40 years, that our children will have a completely different life because they will have to isolate one from the other more or less continuously.
Yeah, but can we?
So think a little bit further, okay? So think about what you're doing in terms of a much longer time scale. And of course, if there's an imminent disaster, okay, you should solve it. Mm-hmm. That's but at the same time, you should live in a long-term perspective, mm-hmm. And that's of course in general missing.
Right. But my question was a more specific one. Can we learn from the models that the physicists have developed for their large-scale experiments to really also advance collaboration in society, responding to large-scale?
I don't think that in COVID it was because of our organization that they organized things that way. But the fact that in a year's time you have a vaccine is due to this focused effort. Okay, so this is how we would have done it, but it's not because they looked at us and they said, "Oh, we do it like those guys," but because there is this huge common goal, which just has to be met.
And then how do we bring that to the ecological challenge?
Yeah, so there, my feeling is that apparently people are only compelled to actually go for the goal when they really feel it.
When they recognize it.
So as long as you just drive your car, okay, you hardly notice from day to day that things are deteriorating. Mm-hmm. I mean, yeah.
So then would you then say?
So it's about times. It's about time scale. It's about thinking about the long-term perspective. And I think in general, humans are not very well adapted to that.
No, we're not.
Which is also completely logical in terms of looking at the evolution, okay? Mm-hmm. Because if something is threatening you today, you should immediately respond to survive. And if it's threatening you in 20 years, you can still produce some offspring and you survive that way.
Mm-hmm. But now, do you believe humans will be ever able to collaborate effectively to answer these kinds of challenges? Are we able intrinsically?
Yes, in particle physics we are. In astronomy we are. Okay, there's more fields like this. So there are fields in which it has been demonstrated. Mm-hmm. So yes, it can be done. But I think what may be important there, of course, is the subset of people that you
it's also selection bias, right? Because it works in physics because it works in physics, and then but maybe in other domains of human endeavor, the conditions are not conducive to actually instill these kinds of collaboration because of whatever competitive forces, resource limitations, what have you.
Well, it's more like a short-term win.
Mm-hmm. Sure.
That is the most destructive force, I think, for these things.
Yeah. But now if you could change one thing in humans in order to make them successful collectively, also as non-physicists, you can change one thing, what would you change?
Probably would help if you could kill the instant satisfaction gene.
All right. Sijbrand de Jong, thank you very much for this conversation.
Okay.
Hi, you listened to one of our podcasts in the series on collaboration, produced by the Instrument Forum and the Convergent Science Network. You can find more episodes on our website.